Hi everyone. My name is Brent Robertson. I'm here to talk to you about optimizing BIM for multi-unit residential projects. Dexel has used BIM technology to design, build, and construct projects here in Halifax and Dartmouth for roughly over a decade. I myself have been with Dexel over the past 8 years and have seen the growth and change over that time. Dexel's CEO Louis Lawin has made exploring new technology innovation a priority for our firm. When he chose to introduce BIM software, the goal was to quickly visualize project potential and to maintain a high level of precision. This has transformed in my time with Dexel to include much more, such as building takeoffs, material breakdowns, delivery schedules, so on and so forth. And just as a note, the program that we use is a little bit different than what's in the community right now. A lot of people use Revit. We actually use ArchiCAD, which was developed in Europe and has kind of made its way over here. So we're a little bit different than some of the other people. Today I'm going to go over 3 of our past projects. One of our projects that is under construction, and one that is in planning stages. So a few of the past projects that we used BIM for was Virtu Suites in downtown Halifax, Avonhurst Gardens, which is in Dartmouth, and St. Joseph's Square, which is in the north end of Halifax. And then our 2 other projects are the current construction at 1343 Hollis, Flynn Flats, and an upcoming one that's in planning stages on Mumford Road. So every project has its challenges, so I'll be trying to take a look at the challenges we faced and how BIM solutions have assisted us to complete some of these projects. So Virtu, located at 1530 Birmingham, is in the center of Halifax. It was constructed in mid-2011 and above Pete's Boutique and was completed in 2013. Some of the challenges that we faced here were building atop an existing roof, managing building materials on a site that actually didn't have a site. Other elements that we were faced with was constructing that 5-story building while the mall below was fully functioning. So we had to have people moving in and out while constructing 5 stories above. And the other one was building close to and within the HRM view planes. We had to know what and where we could build. Combining as-built drawings and survey data, a preliminary model was created to allow us to design the upper structure, and which was planned for but not completed in the initial project of City Center Atlantic. So construction tolerances had to be, we had to allow for construction tolerances in this project, varying from 1 inch to up to 8 inches in the structure below. When we completed our structure on top, we actually completed all of the structure up to the 5th floor, then started to enclose the envelope from the top down, leaving the last floor, connecting them as the last piece to connect all of the building. During all of this, the BIM database allowed us to develop pricing packages that would break down the building into much easier to understand drawing sets. We were able to ensure that while we were building within the 6-inch tolerance of the building below, we were also able to build as close as possible to the view plane, which I'm going to show you right now. So this is the software that we use for all of our buildings. So if you look here, we have the view plane coming down from Citadel Hill. There was an additional view plane in this corner that we wanted to build as much as we could into it, but then decided at the last, or closer to the end, that we didn't want to drop down that much of the roof just for that one corner. So we were able to kind of have a very detailed design reacting to the view plane. In this project, we also created custom panels that required detailed drawings to ensure none of the patterns were repeatable or detectable, and they were easy to install. Although BIM was not used for this aspect, we identified it in the project that it's something that we could better in the future. The final product, Virtu, is a project that I am proud to say I was a part of, and I think has enhanced the urban context of Halifax while adding density to its city core. So the next project we're going to look at is Avonhurst Gardens. So this was constructed in late 2013 at 5 Horizon Court in Dartmouth, and was completed in 2015. Some of the challenges we faced here were design and management of a randomized cladding pattern, which you can see here, and increased material management due to the large scale of the project. This building had 214 units, so it was just a very different scale than what we had worked with before. So some of the strategies that we used to overcome those challenges were developing a BIM object with outside code writer that we could identify every single panel, the facade it was located on, the color it was, the floor that it was intended to be on, shape, color, everything. So if there's a panel on that building, we've drawn, touched it, moved it, adjusted it, changed the color twice, and come back to it. And I'll just show you a quick example. So we had roughly 15,000 different panels in different shapes, colors, and sizes that had to all come together seamlessly and effortlessly. So if you look, every single panel in there can be identified in that way. So we were able to, with our contractors, look at, develop, and create installation drawings with these. Other elements that we were able to do was create detailed delivery schedules. So building 1 we scheduled within a certain time frame, building 2, and we could actually allow the site as they were constructing it to move from facade to facade and let us know when they needed the material. So we had a lot of control over what and where things were moving. In developing that panel, or in getting that 3D object, we found a new way to use it as well. So we decided to look at how we could utilize it for things such as countertops, backsplashes, and any large-scale granite material. So we actually we were trying to push the envelope with what we were using on the exterior and trying to bring it to the interior as well. Our next project is St. Joseph's Square, located at 5450 K Street in the north end of Halifax. Construction started in 2015 and was completed in 2017. This project had numerous cladding types as well as custom masonry to reflect the history of the Hydrostone district. So this is one of our early models and renderings, and the 3D object that I was talking about earlier, we actually used as well for the masonry here, just changing its dimension, size, and location, and we're able to order it quite easily. In this project, we also tried to expand our use of BIM as a marketing tool. So our sister company, Paramount Management, was able to use unit layouts that were directly on the iPad and was able to walk around on-site or with potential residents to see the look and feel of all of the units, amenity spaces, etc. It was also one of the first projects that we had a set of digital drawings on site with our project manager. This allowed them to see complex areas in 3D and, more importantly, share these models and details around the site without having to flip through a 150-page set of drawings. The outcome, in my opinion, was spectacular, and St. Joseph's has become a welcome destination community. So these are just some of the photos of the final construction. And then just moving to our current construction project. It is located at 1343 Hollis Street in downtown Halifax. It is closely surrounded by a number of buildings, notably the Alexandra and the Governor General's House. It is a 43-unit building and has 4 townhouses, a penthouse, and shared indoor and rooftop amenities. Flynn Flats shares underground parking with the adjacent Waterford Suites, and on the corner has also allowed for a small retail space. Challenges we faced here were connecting to an adjacent building's mechanical system. So these 2 buildings are actually sharing mechanical systems. The other one is higher construction costs because of the smaller size of the project. So as we were going to tender for certain elements of the project, we realized that we had to adjust our financing for that reason, because of the smaller scale, only 43 units, harder to reach in the city. We were able to basically redesign elements to make it more feasible for us. With these challenges in mind, we made the leap to use a MEP Modeler, and this allowed us to create detailed drawings of the existing building and plan for complex groupings of bathroom and kitchen types in the building. So this is kind of our building database for all of our door types, wall types, different elements that we can schedule and create essentially a building budget with. It also cross-references with all of the dimensional information that you'd want broken down into the different areas. And we tend to do this at different stages in the project just to assess material, design intent, linking to other buildings. As you can see here, this is the area where we would connect to the adjacent building. So our firm has continued to build a BIM component library over the 8 years that I have been there, and this has allowed us to clearly describe all of the aspects of a project as efficiently as possible. So this project is a project that is currently in permitting stage, and we actually use BIM to place the land use bylaw restrictions around us and to design our building to fit within them. Our firm has adopted and adapted many BIM strategies over the years and will continue to do so into the future. One great potential that BIM gives us is the ability to build something twice, the first time digitally and the second time physically. And that's one of the big things that we try to take on any project that we do, is we do it twice to get it right the second time. So, thank you.